Hello everyone, this is Gaurav Chaudhary and today I'll be talking about CMOS realization of universal gates. Okay, now what is CMOS? CMOS is a technology, means it's a new technology that can be that is used for constructing the integrated circuits, ICs mainly. And CMOS semiconductors uses both NMOS and PMOS technology. We all know about NMOS and PMOS, and that's why I've not taken up it in the slide. So now the representation of NMOS and PMOS are in this way. This particular part is the NMOS representation, and this particular part is the PMOS representation. As you can see, the PMOS representation contains a bubble at the starting. This bubble represents that the input is knotted, means it's the inverted input that is taken in. Now let's come to the main topic and discuss about the NAND gate realization of CMOS in CMOS logic. Now see, as you can see the circuit here, this one is the circuit for NAND gate realization using CMOS. The NAND gate, we all know the truth table for the NAND gate. This one is the truth table for NAND gate. You see, when the inputs are high, the output is low, or when any of the input is low, the output is high. Suppose we are taking the input as 0 and 0. Now the as you can see, the for the PMOS part, when we provide a 0 here, then this bubble, as I said, it acts as an inverter, then the output here will be 1. That means the circuit will be short circuited. This one is your VDD. VDD is the supply voltage, and this one will be shorted with this part where we are receiving the output. That means there will be a logic high at the output. As I can say, when either A or B is low, output is high, or when as this one or when both A and B are high, output is low. Here we can see that both the inputs are low, so the output we are receiving is high. Now we can now let's see the next part. If you are taking one input as low and another input as high, then see what happens. Then let's see the first one. Here the 0 gets here and it gets knotted, it becomes 1, and this part becomes short circuited. Then it starts conducting, the output here receives the VDD, so the output becomes high. Similarly, when we are giving both the inputs as high, let's see what happens. Here we are receiving high, it gets knotted and it becomes 0. This circuit becomes open circuited, and here as well as B also becomes open circuited, and the VDD does not reaches the output. That means the output becomes low. So this is the realization and explanation for the NAND gate realization of CMOS logic. Now there is one important thing that might be of use to you, everyone who's watching. You only have to make the PMOS or NMOS, whatever one part you can make of the circuit, and the other, suppose this one is the PMOS part, so you just need to make only this part. The other part, the NMOS part, will just be the opposite. Means, like, suppose this part, these two transistors are connected in parallel And for the same means for NAND gate realization, and if you using means NMOS logic, you can just connect them in series, just in like opposite configuration you can connect them and you'll get the output. Now again we are back with NOR gate. This is the circuit for NOR gate. Suppose we are giving and the truth table for NOR gate. The truth table for NOR gate, we all know only it's just the opposite of OR gate. Whenever both the inputs are low, output is high, and when either of the input is high, output is low. Now let's see how this thing works. Now suppose we are providing input as both are high, 1 and 1, then what output do we get? So when we are this is our VDD. When both the when A receives 1, this bubble inverts the inverts the result and becomes 0. This one becomes open circuited. That means VDD does not get to the output. That's why when either of the input is high, output is always low. If for the second case, just consider this one to be 0. If this is 0, then this one is high. This one is high because there's a bubble which inverts it. This one becomes high. This one is short circuited, and this one is open circuited. Still the VDD does not reaches the output, so the output is low. Let's see what happens when both the inputs are low. Here we give it 0 and here also we give 0. Let's see what we get. This 0 propagates here, this one becomes 1, this one becomes short circuited. Even this 0 propagates here, this one becomes 1, this one becomes short circuited. So VDD starts reaching the output, so the output becomes 1, that is high. Now you can verify it with the truth table of NOR gate. This is the truth table of NOR gate. You can verify it. And regarding this, if you have any problem, please comment below and ask questions. And that's all. Thank you.